How many times do you have important call? And you realize the battery in your phone is dying. We all have problem with the battery in our cell phones. I'm talking about lithium-ion rechargeable battery. Typically, when you have a battery with one charge, if you are lucky with your cell phone, maybe 3 days, wouldn't it be nice to have longer power batteries where you can charge extremely fast? I'm talking about decreasing your charging from several hours to some few minutes. And also, you wouldn't experience any overheating of your cell phone, which actually end up impacting the performance of your battery. That is decreasing your battery life. But today, I have great news for you. And I'm going to tell you first what Dr. Goodenough, the inventor of lithium-ion rechargeable battery, told us. He said, you guys have solved the anode problem. And this is the reason. We are SurgePower Materials. We produce a green technology material called graphene. Our graphene material is made from a cassava plant. And we use a very simple process to convert this into our graphene material. And when you use our graphene material to replace graphite, that is what we all have today in our cell phones, you will end up having a capacity which is almost 5 times of the standard graphite. In addition, you can decrease your charging time from several hours to some few minutes. And our material has been evaluated by third party for testing because we don't have in-house capabilities to make the cells or even to test them. And the data we got shows that almost more than 1,000 cycles, there was almost no degradation of our battery. And most importantly, we don't have any explosions yet. And this is the reason. With our cell phones right now, the material which is in it is called graphite, like I said before. Think of graphite like a book containing several leaves. The truth of the matter is, anytime you are charging your phone and discharging it, the lithium ions has to go in and out of the graphite. Think of it like all of us in this room. Trying to rush out of the door at the back is going to be chaos and disaster. That is what happens when you try to charge your phone extremely fast, whether you are using a high amp charger or other means. But with our technology, the SP2 hybrid, the spaces of the sheets are completely separated out in the form of 3D way, so the lithium ions can easily go in and out, thereby giving us the opportunity to charge our batteries extremely fast. On top of that, there is more space for the lithium ions to stay, and that's why we have improvement in capacity. The data you see on the screen shows a technical data which we got from third party after we gave our sample to them and they gave us the data. A typical graphite has a capacity which is roughly around 300. The theoretical is actually 370. But compared to our data you see on the screen, which is in the green dot, we are close to almost 2,000. And this is why we say we have a capacity which is more than 3 times that of the standard graphite we all have today in our laptops. The graphite market that goes into lithium-ion rechargeable for the US market alone is more than $2 billion. And this is a breakdown of it. We all know the EV market is growing. And also, currently, majority of the lithium-ion batteries in the mobile sector. Our technology is patent pending. We also have a lot of trade secrets. The technology was invented by myself, and currently we are able to produce substantial amount of samples, up to almost 75 grams a day. And we have plans to improve our, to scale up our process, and I'll talk about it in a very short time. So are we the only graphene producer out there? The answer is no. Graphene technically was discovered almost 15 years ago. There are so many startups that are producing graphene, and I'm showing two of them who are major players in the supply chain in the US. But the key here is we are completely different. All these other graphene producers at the marketplace, their starting material is graphite. They take the same old graphite I showed earlier, and they use very harsh chemicals to push out the sheet out and do a lot of washing. It's a very complicated process. At the end, the product which most of them are getting is the numbers you see on the screen, on average. And the price of that is extremely high, almost $500 a gram. With our technology, our starting material is here, and I'm going to test it for demonstration purposes. We use a green synthesis method, which meets 8 out of the 12 principles of green chemistry to convert this cassava into some of the graphene samples which I have here. And the results we get is very remarkable. We get almost 4 times the surface area of any graphite which is being sold, any graphene which is being sold at the marketplace today. On top of this, we also get 5 times the pore volume, which is very critical for energy storage, because the electrolyte, you have to push things in and out of this material. And that's why we have the ability to fast charge and also have more capacity. This data came from an external company that did all these tests. The end result is we end up with a very low cost-effective manufacturing process. This is our great team and talented team. Myself, I'm the CEO of the company. My background is material science. I have a PhD in material science and engineering. I also have another PhD in chemical engineering, and I invented the technology. I'm also joined by George Steinke, former VP of Schlumberger. George has more than 40 years of experience in leadership positions and is also a serial entrepreneur. He has had so many successful exits with some of his companies. I'm also joined by an experienced process engineer with 40 years working for Thermon. Greg is actually also an investor in our company, and he retired and joined us this summer. I also have here Dr. Gary Bale, a serial entrepreneur with almost 6 companies, worked in the industry for more than 25 years, also joined academia, and has 48 US patents. On the advisory side, we have very talented people in the marketing side, the finance side, and we also have the inventor of lithium-ion rechargeable battery on our team, Dr. Goodenough. Up to now, I've been mainly about the energy storage capability of graphene, but I want to let you in on a secret. Graphene has so many other interesting properties. It's transparent, flexible, and thin. That means in future, you will end up turning all your windows into screens. It also has one of the highest thermal conductivities. This same material I'm talking about is more than 100 times stronger than steel. In fact, it's almost 50 times stronger than carbon fiber, which has been used a lot to reinforce a lot of composites and so many other applications. And it also conducts electricity better than copper, which is all around us in so many of our infrastructure systems. But we are a startup, and we have a small bandwidth, so we can't focus on every application. That's why we are focusing on the active material for batteries and supercapacitors, although we also have some other companies in the composite world who are also contacted us to use our material for composite applications. So for NASA, this is a typical example of where we can utilize our material for NASA application. Currently, the Curiosity rover has a thermoelectric generator system. However, it's also backed up by 2 lithium-ion rechargeable batteries. So is the next rover, which is going to go to Mars. And we believe we can play a role in the energy storage area for NASA. And Kathleen, we believe we can help you with your power systems, with your mining robots. Marketing strategy is basically two-tiered. We are partnering with battery manufacturers. And currently, we have our product with almost 3 different major battery manufacturers who are evaluating our material. The other second tier is also to partner with additive suppliers, the people who actually supply the graphite and all the other ethylene black to the battery manufacturers. We have also almost up to 4 or 5 of them we are talking to right now, and some of them they've requested large samples, which unfortunately we cannot produce now. And we've given them some time before we can do that. On the composite side too, we also have a Fortune 500 company that also wants us to develop our graphene for other applications. Currently, we are in partnership, we have sponsorship partner agreement with Texas State University, and we utilize one of their lab space and also one of their offices over there. We have our own unit also in the Braunfels, Texas area, but the Texas State one is for the early development of our technology before we move into our pilot unit. We have also Ecliptic Ventures, and that's been supporting us. They are venture capital, but they join us to do early investment to help us kick off our company as quickly as possible. Why we are here today is that, like I said before, we don't have the infrastructure to make the cells or even to test them. And that's where we need NASA help to evaluate our material under so many different conditions for some of NASA applications. So this is where we are currently, and this is our milestone for production. I know you guys see probably so many animals over there, and some of you feel like you are going through the jungle right now. But this is the key. As we scale up our process from the jackrabbit plant all the way to the elephant, we will be able to have the capacity to produce almost an active material for 1 million Tesla vehicles. Tesla produced almost 250,000 vehicles last year, and they are planning to, their target is every quarter almost 100,000 vehicles. So we are kind of making our projections in line with some of the electric vehicles. But the key here is that our product at scale will be very competitive with graphite, yet we are going to offer all the advantages of fast charging and improvement in capacity. Our company started by myself and a few others, and we bootstrapped a little bit. We made some contributions to put in the money, and we also have involved in so many business plan competitions. And we raised some money to start off and start improving our material and our process, and also to make big quantities. And fast forward to last May, we received money from VC and also from Angel Networks in the Austin area, Texas. And on our seed, we have finally finished our seed, but the second tranche of the money will be coming in November. But next year, we will start our Series A, and that's where we need help. Our Series A is almost $4 million, although by the end of next year, we will be very profitable because we will be cash flow positive with almost more than $2 million in revenue. That will not still be good enough for us to kick off our Buffalo plant and beyond. In summary, we are SurgePower Materials, a green technology company producing a unique form of graphene for so many diverse applications. And we want you to join us to bring our product to market. We want you to join us, power the world and beyond. Thank you.
I have a first obvious question. You've got claims here that you get 5 times the power and charging within 2 to 3 minutes. Have you got a prototype or a test where you've got current technology tested against this claim?
But yes, like I said, so I have some of, although it's not a very huge batteries which we made at this point. Yes, so the numbers you showed there, which I showed there, and actually, I don't know, go on. Can you go to the other direction, actually? Go one more. 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 Yes, here. Okay, that's good enough.
Thank you.
Yes. So at the end of 2017, Samsung actually came out with a graphene silicon-based material. So what they do is the silicon, they call this graphene balls. So they coat the silicon with graphene. And the test you see on the, so the test you see on your right-hand side is the Samsung data. You haven't modified it, it's exactly the way it was published. And if you look on the left-hand side, that is our data. And you can see clearly that in terms of capacity, the truth is the Samsung data actually shows improvement of almost 2 times in terms of the anode capacity. But compared to ours, we are almost more than 2.5 times even that of the Samsung technology. So I hope I answered your question.
So these are full battery tests or half cells?
No, these are half cells. So we are now partnering with other companies like Southwest Research, but they said that big pouch cells, they cannot do it, but they can evaluate. So they recommended other people we should talk to do the big pouch cells for us.
So you showed results for 5 cycles. What happens if you go to 1,000 cycles?
The 1,000 cycle data also, we are, let me see. If you can go more. Okay, can you go one more? Okay, so, yeah. So there is some other data which we have there. And like I said, yes, when we evaluated our samples, we see almost no degradation in performance even over the 1,000 cycles. And there's more data which I can show in the closed session. Yeah, that's okay.
You showed a dramatic increase in production capacity 2 years from now, if I remember the chart right. Is raw materials going to be a problem, or is the raw material supply sufficient?
Yes. So currently, with our increase in capacity over the years, currently there's almost 270 million tons of cassava is being produced right now. And with our capacity, so let me break it down a little bit. Every acre, you will end up getting roughly around at least 20 tons of cassava. And with that 20 tons of cassava, almost 65% of it will be converted, will be the raw material which we need to make our material. So in terms of the production scale, roughly we are still within, let's say, 20%. But the truth of the matter is cassava is a renewable plant which takes roughly 6 to 9 months to harvest. So we wouldn't be having that kind of problem, and it could be grown anywhere. In Texas here, in fact, it thrives in arid conditions. And the World Food Organization actually recommended that cassava should be interplanted with corn or soya beans, and yet it's not going to affect your yield. And the corn industry and all the other industries, yes, you can interplant cassava, still no reduction in your yield.
I was interested in what you said about the fact that your material has a higher thermal and electric conductivity. Is that higher than standard graphene as we know it? I mean, do you get higher thermal and electric conductivity than standard graphene?
The answer to that is on the theoretical level, no, we don't reach the theoretical. We don't reach the theoretical, no, we don't reach, yeah.
Are you open to other sources of the product other than cassava? Because I understand that gum trees are also another source being looked upon. Do the two, they grow in different environments and that kind of thing? Just kind of share.
Yes, so you're 100% right about the gum tree. So that one is a little bit different. And with our source of material, although I can't disclose all of them, we have a lot of plants, basically, which we can convert all of them into graphene. Yes, so I don't know if I answered your question. So we have a variety of plants.
So if you use a gum plant, does it change your product?
Oh, that was the question. Oh,
Is that what you, it's part of it, I was just.
okay, yes.
Wondering if you could just share the
Yes.
green nature of this.
Oh, okay, I see. So with all the raw materials which we use, although I don't want to disclose too many of them at this point, we go through a very three basic way to characterize it to end up getting our graphene. The first one is more like a quality QC test. And all what we do is because different plants sometimes have different minute amount of different elements in there. So the first Q2 test is basically to eliminate all those kind of other elements which we don't really need in the plant. And the rest is just straightforward. But for now, with the cassava, it's more pretty straightforward. But with other complex kind of plants, yes, we have to go through other processes to get some of the other elements in there out.
Thanks very much, Michael.
Thank you.